Tsunamis. One of the most unpredictable and deadly forces of nature. They can attack crowded tourist areas and busy coastal towns with murderous intensity and little warning. Most tsunamis are caused by earthquakes, but there is another deadly kind waiting to strike. Volcanic landslide tsunamis. Some experts believe a landslide tsunami could devastate the east coast of the United States, from Boston to Miami.
Imagine a river in flood coming towards you.
20 or more 50 to 100-foot waves wiping out everything in their paths.
A 100-foot wave. Not only is it going to take out the dune line and that first row of buildings, it's going to keep coming in.
Boston's harbor destroyed. New York City decimated by flooding. Beach towns from New Jersey to South Carolina in ruins. Miami nearly cut off from the rest of the country. The nation's economy ruined. They've happened before in other parts of the world. They can happen again. And they can happen here.
That's why when we talk about being prepared, it's not just for the threats that we can see coming. It's for the threats that we may not even know exist.
Some scientists believe a mega tsunami could someday devastate the entire eastern seaboard of the United States. It would start here on La Palma, a tiny Spanish island off the coast of West Africa in the Canary Island chain. La Palma has an active volcano named Cumbre Vieja. Sometime in the future, it may reawaken. The entire island rumbles as jets of steam and ash explode into the air. Suddenly, the 3-mile crack that runs north to south along the ridge of the volcano groans and ruptures with a ferocious roar. An enormous section of rock and dirt more than 10 miles long and over a mile high shears off Cumbre Vieja and crashes into the ocean. As the volcano wall hits the water, it creates a huge wave around the island that reaches up more than 1,000 feet in the air and gives birth to a mega tsunami. Within 10 hours, the La Palma tsunami could bring a wave of death and destruction to the entire eastern seaboard of the United States. Boston would be overrun with huge 80 to 90-foot waves. In New York City, deadly water would invade Lower Manhattan's financial district. In Florida, cities like Miami could suffer almost complete collapse. The tsunami would end up affecting the entire Atlantic basin.
So this won't be just a local event, it won't be a state event, it won't even be a national event. Like the Indian tsunami, it becomes a world event with worldwide consequences and worldwide impacts.
The images of the 2004 Indian Ocean disaster brought the very real dangers of tsunamis to life. Most Americans believe that the east coast of their country is relatively secure from this kind of disaster. But giant killer waves caused by massive landslides have occurred all over the world, including Hawaii. And they serve as sobering reminders that there is a real threat facing the East Coast.
Hawaiian Islands have a very long history of tsunamis, landslides, And we see it all down the chain. Lots of evidence for submarine landslides, and those landslides almost invariably created tsunamis.
There are over 60 landslide debris fields around the Hawaiian Islands that lie in silent testimonial to the size and power of these collapses. In the area off Oahu, giant rocks fan out in a remarkably ordered fashion along the seafloor. The largest rock, the massive Tuscaloosa Seamount, is almost 30 miles wide. These rocks slid into the ocean during the Nuuanu landslide approximately 2 million years ago. This massive landslide created huge 1 to 300 foot waves that struck as far away as the west coast of America. Today, it is hard to comprehend a 30-story wall of water smashing into the shores of Southern California. Damage would be immense and total for anything within several miles of the coastline. The key shipping ports in Southern California would be destroyed. Los Angeles International Airport, just minutes from the beach, would be flooded with water. There are more than 5 million inhabitants in Los Angeles and San Diego alone. Hundreds of thousands of people live within 2 miles of the ocean. A Southern California tsunami equal in size to the Indian Ocean tsunami of 2004 would cause many thousands of fatalities. Iconic beaches like Venice and Malibu would disappear in the foaming waves, sending thousands of multi-million-dollar homes and their owners to a watery grave. But luckily, 2 million years ago, no one was home. Dr. John Smith uses sophisticated sonar systems and advanced submarine technology to map tsunami landslides around the islands of Hawaii.
So first you would map these from a surface ship with seafloor mapping systems, and then eventually to do the sampling, you might need to go down and look at it in a submersible and take some sampling gear.
Scientists use the data gathered during these trips in the submersible to create remarkable maps of the debris fields. This mapping of underwater seafloors, or bathymetry, is accomplished by sending sonar pings that are bounced off the seafloor and back to the surface boat. By correlating the data from these underwater expeditions, scientists have been able to gain a clearer picture of the history of past landslides and tsunamis. After the Nuuanu tsunami, the last 2 landslide tsunamis to hit the Hawaiian Islands were Alika 1, 240,000 years ago, and Alika 2, 120,000 years ago. Both were caused by landslides on the west coast of the Big Island of Hawaii. The 2 Alika landslides each sent over 500 cubic miles of material into the sea and tumbling along the ocean floor. The Mount St. Helens landslide, by comparison, sent only 1/500th of that amount crashing into the valley below.
And here we are under the abyssal seafloor, about 4,000 meters. So right now we're in the middle of the debris field. You can see these blocks. Some of those are anywhere from house size to building size to car size, and they're all kind of arranged in a fanning pattern as the energy dissipated as it got to the flat seafloor.
Continuing across the ocean floor takes us to where the resulting giant tsunami first hit Lanai, a remote island 100 miles north. 600 to 1,000 foot waves attacked the palm-lined shores of this bucolic spot. Huge underwater boulders, fish, seaweed, shells, and sand were all caught up in the massive waves that rained down on the beaches and hills. Dr. Gary McMurtry, a geochemist at the University of Hawaii, has studied these tsunami deposits on Lanai. These deposits may hold clues as to what would occur in an Atlantic volcano tsunami. Standing on the beautiful and tranquil beach today, it is hard to imagine a giant wave overwhelming the island.
Imagine, if you will, a series of waves over 1,000 feet high coming this way. The color would not be blue, it would probably be white or perhaps brown with all the sediment mixed with it. Perhaps would pull back the ocean, or perhaps it would be more like it is now, but it would come and it would keep on coming
A luxury resort was recently built right on top of the spot where the first tsunami came ashore.
Well, here we are, folks, Archaeology Gully. What we have here is a nice section which shows two distinct tsunami deposits separated in time and also in space. You have the Alika Phase 2 at the top at about 120,000, and down here you have the Alika Phase 1 at about 240,000. These kinds of deposits are not just unique to Hawaii. We see them throughout the world, and they usually come from the collapse of oceanic volcanoes.
The Alika 1 deposit reveals three distinct sets of waves. The first set picked up very large chunks of mostly marine material. The second wave picked up a mix of ocean and land-based material. But the third wave really indicates the incredible strength and size of this ancient wave event.
This is definitely no wimpy wave. This third one, it was picking up some very, very large rocks. Big ones, small ones, rounded ones, some of them are angular, shells. It's chaotic.
The Lanai deposits are compelling evidence that landslides can cause massive, destructive tsunamis. A similar collapse at La Palma in the Canary Islands could produce 50 to 90-foot waves up and down the east coast of the United States. If it comes, the death and destruction will be enormous, and it will take years for the nation to recover from this mega disaster. In the near future, a catastrophic collapse of a volcano in the Canary Islands could trigger a giant tsunami that could wipe out the entire east coast of the United States. It's happened before in other places around the world. Massive tsunamis devastated the Hawaiian Islands hundreds of thousands of years ago, sending 300-foot waves as far as the west coast of the Americas. And these disasters have continued to torment coastal areas time and again over the last 100 years. Ritter Island. This volcanic island off the coast of Papua New Guinea erupted in 1888.
These smaller volcanoes collapse, just like the big volcanoes in the Canaries and Hawaii.
Sketches made of Ritter by colonists before 1888 show the size and scale of the mountain before its collapse.
Two features ridges and gullies that are left on the little remnants of the island that still remain. We're pretty confident about the size and shape of the island before the collapse.
95% of it fell into the ocean, and it made a huge tsunami wave that destroyed lots of native villages.
The eruption triggered a tsunami with 30 to 50-foot waves that killed as many as 3,000 people on nearby islands.
We have descriptions of how the adjacent islands had all the vegetation near the shoreline ripped off. Even years later, the islands had this sort of bald strip around the shoreline where all the trees have been ripped away.
In the last 2 decades, Ritter has become a focus of tsunami research. Dr. Simon Day has spent years collecting and studying the data on this landslide. He and his colleagues crisscross the ocean floor, mapping the length and size of Ritter's debris field. The power and speed of Ritter's collapse is vividly captured in these rarely seen photographs taken along the ocean floor around Ritter Island.
So we see these tremendous grooves extending across the seabed. So we get a strip of photographs showing how the landslide deposit varies across the seabed.
Scientists were eventually able to conclude that the debris field entered the water at approximately 100 miles an hour. With the mapping of the ocean floor, Simon and his fellow scientists had solid information on the size, shape, and speed of the landslide. They also had a wealth of information from the accounts of early missionaries.
In 1888, the area was just beginning to be colonized by Europeans. Although nobody who was close to the island at the time survived, further away there were all these colonial stations, mission stations.
The early settlers on the nearby islands kept detailed records of daily events. Their scrupulous notes provide crucial data and information that help today's scientists predict the size of future tsunamis. In addition, the missionaries had important technological tools that would help determine the timeline of the volcanic eruption on Ritter Island and subsequent tsunamis, watches and clocks. There are other historical accounts of volcanic collapses triggering tsunamis, including several from Japan in 1640, 1741, and 1792.
But in none of those places did any of the observers have watches. And the importance of watches is that they allow you, and they also habituate you, to recording time exactly.
As the waves hit nearby island shores, the Germans used their watches to time the various wave sets. They also made meticulous diary entries on the size of the waves and the time of day that they hit the different islands around Ritter.
It was very like what the tourists did, who saw the Indian Ocean tsunami coming towards them from their hotel balconies. They got out their video cameras and they recorded the waves coming towards them. And we have a lot of data from that as a result.
100 years after the event, scientists were able to correlate the information about the size of the waves as they hit Papua New Guinea and other islands, with the time of day that the waves hit each island.
From those observations, we can make an accurate reconstruction of how the waves within the tsunami propagated out around Ritter and affected the coastlines up to hundreds of miles away.
Using this data, scientists devised a computer model to predict the size and power of future tsunamis. Based upon this model, some scientists now believe that a giant landslide on the island of La Palma could cause enormous destruction from Africa and Europe to North and South America. A tsunami caused by this landslide could be larger than any other recorded landslide tsunami. There have been other landslide tsunamis that hit the coast of North America. The Grand Banks tsunami of 1929 struck the coasts of Nova Scotia and Newfoundland. At the time, tsunamis were thought to be exotic and remote natural disasters that struck in places like Japan and Hawaii. The idea of a killer tsunami along the northern Atlantic coast was inconceivable. The quiet fishing villages along the eastern coast of Canada were completely unprepared for the deadly set of waves that were about to crash down on their homes and businesses. Dr. Stephen Ward has created a computer model that simulates the intense action in the Grand Banks tsunami.
This landslide was started by a small earthquake by magnitude 7.2. It generated a tsunami in the way that landslides do. By moving that material from the top of a slope, moving it down slope, you essentially set up ripples in the ocean, and those ripples can be basically as thick as a landslide is thick itself.
As it crashed to the ocean floor, the sediment sliced through the heavily protected transatlantic cables that run from North America to Europe.
They cut those ocean cables like they were string, and ocean cables are not string, they're usually heavily armored. It's quite an amazing thing.
The tsunami sped toward the Burin Peninsula on the coast of Canada at over 500 miles an hour through the frigid waters of the North Atlantic, showing how fast tsunamis can move through deep water. As the waves neared the shallow shoreline of Canada, they slowed, but grew in height.
By the time they got to the shore, generated tsunamis of about 6 meters, and in the process, people were killed right along this peninsula here.
2.5 hours after the earthquake shook the Burin Peninsula, the tsunami struck hard along 30 miles of Canadian coastline. At least 27 people died, and more than 10,000 were left homeless. Businesses and fishing boats were destroyed. Property damage was reported to be more than $1 million, $20 million in today's dollars.
Our port facility has just been wiped out.
35 years after the Grand Banks landslide tsunami, a giant wave wreaked havoc on another remote and cold shoreline of North America. Valdez, Alaska, 1964. A massive earthquake, magnitude 8.4 on the Richter scale, the largest earthquake ever in North America, sent tremors up and down the Alaskan coast. A localized underwater landslide sent a tsunami wave into the heart of the port of Valdez. Dock workers, women, and many children were pulled to their icy deaths as a 4,000 by 600-foot area of the shore collapsed under the sea. Tanks at the Union Oil Company ruptured, starting a fire that wiped out most of the few buildings still standing after the earthquake, the landslide, and the tsunami. In Valdez, 30 people were killed, and more than $15 million in damage was reported. $90.5 million in today's dollars. The most destructive tsunami ever recorded in North America. But today, the greatest risk for a landslide-triggered tsunami is at Cumbre Vieja volcano in the Canary Islands.
It's only the islands like Hawaii, the Cape Verde Islands, and the Canary Islands that are big enough to produce these giant 100 cubic mile landslides that are capable of producing giant tsunamis bigger than any that's been produced in recorded history, and that can produce huge damage over transoceanic distances on the other side of the ocean.
These waves would head straight toward the east coast. A tsunami like this could spell disaster for the United States. Tsunamis from volcanic landslides have devastated shores around the world about every 10,000 years. Today, one of the biggest risks for a landslide tsunami facing the United States is 3,000 miles away on La Palma in the Canary Islands. The greatest cause for concern is a jagged crack 3 miles long on the western side of a volcano called Cumbre Vieja. For geologists like Simon Day. The 15-foot wide crack in the earth is evidence that the west side of the Cumbre Vieja volcano is slipping ominously toward the sea, possibly faster than anyone had previously anticipated.
This side has gone down relative to this side by about 4 meters as this area moved off towards the sea. And this is something quite unusual, quite unique, that you don't normally see on volcanoes.
If another eruption should cause the crack to suddenly rupture, a landmass 10 miles long and more than a mile thick could slide into the sea. Killer waves could strike from Europe and West Africa to North America and South America. The question is, will it break? And if it does, what will happen? How would this deadly mega-disaster get started? The answer lies in the geology of the mountain itself.
Cumbre Vieja is a relatively young volcano on the island of La Palma, which is probably closest to the active hotspot that's creating the Canary Islands. And we know that these volcanoes are actually most dangerous in their prime, when they're largest.
The volcanic island is more than 12,000 feet from seafloor to the surface of the water, with another 6,000 feet above sea level. The height of the volcano is more than 18,000 feet. Volcanoes like Cumbre Vieja are actually made up of countless individual rocks, formed by lava over thousands of years.
Like all volcanoes, they tend to build up in layers and sheets, and they become unstable like a stack of shingles.
Cumbre Vieja has erupted several times in recent history, and there are 500 years of historical records since the Spanish arrived in the islands.
During that 500 years, there have been 6 eruptions, and most of those have followed a similar pattern.
One of the significant findings of geologists is the importance of rain in the makeup of these volcanoes.
There are a number of non-volcanic landslides where water pressure seems to be very important. The reason why landslides often occur after rain is because the rain soaking into the rocks increases the water pressure.
Over the years, the porous mountain itself was collecting huge amounts of rain and storing the water deep inside the volcano.
Volcanoes are like giant sponges. They get filled up, and that extra weight creates an unstable situation.
Within the interior of the volcano, there's this huge volume of rock that is saturated with trapped water.
Beneath the surface, the water collects in pools and streams between the volcanic rocks. As the lava starts to rise toward the surface during an eruption, it begins to heat the rocks around it. This boils the water and turns it into steam, like an overheating car radiator. Eventually, the pressure from the steam pushes against the rocks and starts to push them loose.
So this isn't something that we've understood for a very long time in the context of things like pressure cookers and boilers. But it turns out that the same thing happens with volcanoes.
It was likely that 7 days of heating and pressurization of the groundwater is what destabilized the flank of the volcano in 1949. Another earthquake could enlarge the crack and threaten the stability of the mountain and ultimately cause a landslide. The awe-inspiring collapse at Mount St. Helens involved a cubic mile of material crashing into the valley over a period of 10 minutes. A La Palma mega-landslide would be 200 times bigger and would last around 4 hours. Once the fault is fully broken through and the mass of rock on the western side of Cumbre Vieja is free to move, it will start crashing downhill very rapidly.
collapse of La Palma Island involves 100 cubic miles of material, and it's falling from so high to so low, the energy involved in that is more than all the nuclear weapons on Earth.
The landslide will exert a huge amount of energy as it plunges toward the ocean.
La Palma is very steep, one of the steepest places on Earth. So this 100 cubic miles of material is going to accelerate to 200 miles an hour, 300 miles an hour, and is making a huge bulge of water in front of it. And that bulge of water is going to propagate out at 500 miles an hour and cover the Canary Islands in about half an hour. You can see it's basically a volcano, and a big hunk of it near the top breaks off and slides down into the deep part of the ocean. In the process of breaking off, it generates the waves, hundreds and hundreds of meters initially, and spreading out over the whole Atlantic basin. In the left screen here, we're seeing the tsunami very close to the island, maybe 100 miles radius from La Palma. There is very, very large, very high, and very compact.
The next frames show what happens after the initial generation. The wave circle starts out small, but then expands to take on the entire basin of the Atlantic.
We're not going to get 3 or 4 giant waves arriving on the American coastline. We're going to get 20 waves, but they're still going to be very big. It's not going to be 200 little tiny waves. It's going to be 20 big, damaging Sumatra tsunami-sized waves.
And the east coast of the United States would be directly in the path of this deadly onslaught. To many people, the idea of a tsunami on the east coast, triggered by a landslide 3,000 miles away, may seem unbelievable. But these killer waves could be on their way. Using Ward and Day's computer models and state-of-the-art CGI animation, we'll take you down to the shore as a massive volcano-triggered tsunami comes roaring up on land, tearing buildings from foundations, and leaving a wake of death and destruction from Maine to Miami. It would probably begin like this. The Cumbre Vieja volcano in the Canary Islands would start to rumble ominously, and then erupt. Based on previous experience, some scientists believe that shortly after the first eruption, earthquakes will begin to shake the island. The 3-mile crack along the western ridge will suddenly widen like a zipper along 10 miles of the western face of the mountain. If this section of the mountain were to slide into the sea, a mega tsunami would start to move across the Atlantic Ocean in every direction. Meanwhile, scientists would furiously analyze data in hopes of determining if and when the volcano will suffer a catastrophic collapse, like the Ritter Island collapse in tsunami in 1888. It is a horrifying possibility, but a real one. And the stakes are high. Emergency management experts and government officials around the rim of the Atlantic Ocean frantically consider whether or not to start evacuating. Tens of millions of people in towns and cities line the shores from Europe to North Africa and North and South America.
The problem for the emergency managers is then, do they start evacuating at that point when the landslide hasn't happened yet, but there's a possibility that it may do, but it may not?
While emergency personnel along the east coast of the United States scramble to get prepared, across the ocean, the mountain continues to ominously shift and crack.
And of course, once it starts moving, it gets weaker, the rocks are broken up, there's less resistance to further movement, so provided the pressure of the water is maintained, that's the point at which you can go off and produce one of these giant landslides.
The western face of the mountain drops 20 feet toward the water below. Then, suddenly, a massive wall of rock 10 miles long and 1,000 feet thick, approximately half the size of Manhattan, slides into the ocean. The 200 cubic miles of rock sends up a wave over 1,000 feet high around the island. It is the beginning of a worldwide catastrophe. First to be hit by the giant waves are the surrounding Canary Islands. The waves spread out in every direction. A wall of seawater more than 300 feet high hits the west coast of Africa, destroying such landmarks as the famed Mosque of Hassan II in Casablanca, and killing thousands. Out in the open waters of the Atlantic, the waves heading in the opposite direction speed across the ocean at the same rate as a jet plane.
These energy waves can transmit quite nicely in this medium. Even though it seems like it's very, very far away, they travel pretty much intact.
The wave grows by about 3 or 4 times, again, just like waves at the beach. And so the 10-meter wave in the middle of the ocean will grow back to about 30 meters when it comes ashore.
Some scientists feel that this computer model, in which a collapse of Cumbre Vieja and La Palma generates 30 to 100-foot waves almost 3,000 miles away, is inaccurate. But other experts feel strongly that recent research at Ritter Island and other locations have confirmed these mega tsunamis are possible. At 9 hours, the first of 20 90-foot waves obliterates mid-Atlantic islands like Bermuda. Caribbean islands such as the Bahamas are completely overrun. 10 hours after the landslide, the killer waves simultaneously attack cities and towns all along the East Coast.
There would be a wall of water that would probably hit the East Coast anywhere from Newfoundland all the way to Florida to Miami.
The first wave will start to near the shoreline up and down the coast.
When the tsunami wave gets into shallow water, 2 things happen. So here's one wave crest, moving along, slowing down as it comes into shallow water. The next wave crest is coming along behind. It's moving faster because it's still in deep water. So the wave crests get closer and closer together.
With more waves starting to approach the eastern seaboard of the United States, emergency services scramble to prepare for the worst. But they are quickly overwhelmed.
When you look at tsunamis and you look at all the disasters that happen, we tend to do a scale of what is the frequency and likelihood of occurrence and what are their impacts. And there's a point at which you kind of run out of resources to do everything at the same level.
Sirens are blaring in every coastal town. Residents try to make last-minute provisions for escape.
If you look down, you see all these people on the water's edge. A small tsunami, it may only mean that they have to get off the beach and get to higher ground to save their lives. But in bigger tsunamis, where the ocean meets the Florida coast, you could be talking 40, 50, 100-foot tsunami. In that case, not only do you have to get off the beaches, you're going to have to get high up in the buildings. And you look and you see in the background, you see these buildings. Many of these buildings may be the only refuge. People will have to get up in them and get up quickly if the tsunami hits the Florida coast.
The cities and towns on the east coast of the United States hunker down for what could be one of the deadliest natural disasters in history. It's a frightening prospect, but it could happen tomorrow. An eruption of the Cumbre Vieja volcano in the Canary Islands triggers a massive landslide and starts a mega tsunami. Giant waves rush west across the cold Atlantic waters. After traveling 9 hours, the waves near the eastern coast of the United States. Waves crash into the Outer Banks, a string of barrier islands off the coast of North Carolina. After this first assault, the swells finally make it to the mainland.
It's not just one wave. It's not like a Hollywood movie where it goes splashing over. It's a long sequence of waves. In fact, the biggest tsunami may not be the first. It may be the second or third.
The rising water hits Boston Harbor and other parts of the mainland almost simultaneously. In New York City, waves crash into the financial district in Lower Manhattan, sending a lethal flood of debris miles inland.
So what the debris looked like in Indonesia with that tsunami. You get all the mud and all the trash that's in there and literally sweeping people up. You're in a soup of lethal projectiles, mud, and fast-moving water.
Further south, resort towns and coastal cities all along the mid-Atlantic states drown under massive seawater surges. The water is relentless.
It's going to be 2 feet, then 5 feet, then 7 feet, then 12 feet, then 40 feet over a half an hour. And then that's going to drain back out over another half an hour and basically repeat itself a dozen times.
What the tsunami doesn't get in the first set of waves, it will rip apart in the next.
First wave's going to come in, and the sea's going to go out, and the next wave is going to come in 10 minutes later, and the next wave's going to come in 10 minutes after that. And of course, if one has maybe 20 large waves, the whole thing might last 3 or 4 or 5 hours quite easily.
If that type of tsunami is possible, you're dealing with a catastrophic event that would probably even exceed some of the most powerful hurricanes due to the water damage along the coast. In the state of Florida, close to 8.5 million people are in a threat zone.
In Miami-Dade County, an urban area of 2.3 million and growing, the vulnerable and low-lying areas east of I-95 are sitting ducks for the huge waves.
And all that water pushed in is going to flood well beyond the beaches.
90-foot waves invade the beach areas. Smaller deco hotels along the beach disappear under the waves, along with the few thrill seekers still at the beach.
When you have water going 20 miles an hour, that exerts a force of about 3,000 pounds on you if it hits you. Anybody who's ever walked across a stream knows that. You lose your footing because all the pressure of the water pushes you sideways.
Imagine a river in flood coming towards you. That's what a tsunami is like, rather than the sort of plunging breaker that you'll see a surfer riding that curls over and breaks and doesn't come inland.
In Miami, emergency management officials struggle to get people west of I-95 as water starts to flood across the flat lowlands around Miami-Dade County.
Basically, it's between US 1 and I-95, the interstate system, that is the highest point along the coast. And generally, if you can get beyond that point, you're generally outside of the worst part of storm surge areas.
After 4 or 5 hours, the worst waves have finally subsided, but it's not over yet.
But you got to survive the event. That's the first step. And the second part of what we generally talk about with disaster supplies is surviving the aftermath. What's going to happen after the tsunami will be equally critical for the survivors, because much of what they depend on a day-to-day basis may be destroyed or not functioning for days to weeks to even months.
Government organizations like FEMA may be unable to cope with a disaster that strikes more than 1,000 miles of coastline. Infrastructure will take years to return to normal.
This is one of those events that would put the United States in a position that we have never found ourselves in, and that is being dependent upon other nations to assist us in our time of need.
If this mega disaster ever hits, it will impact the east coast of the United States for years and will have worldwide repercussions.
That's going to affect long-term the entire face of the eastern seaboard and our economy. In effect, those areas that are not in that strike zone, the Midwest, the West Coast, will be managing and supporting the East Coast for years as that rebuilding takes place.
But with recent increased awareness, there is some room to be optimistic that the nation can survive a catastrophic event such as this. A tsunami warning system already exists in the Pacific. A recent bill in Congress includes funds to install 6 additional sensors in the Atlantic in case of an East Coast tsunami.
I would like to think that those thousands of people that died in Asia didn't die in vain. And I think that we now know that it's really important to have a good warning system in place. And it can't just be a basin-wide system like we have in the Pacific, but it has to be a global system, for the Atlantic, for the Indian, as well as Pacific Oceans.
Volcanic landslide tsunamis may not be as common as hurricanes, tornadoes, or earthquakes. The last major tsunami to be caused by a landslide occurred in 1888 at Ritter Island. But when they do occur, they can alter the face of the Earth in ways that mankind has only imagined. The threat is real, and the death and destruction will be catastrophic.